Okay, we're going to go over our first lesson on probability here in Honors Algebra 2, which is some basic probability principles and then frequency tables and distributions. So what I'm going to start off with here is just what needs to be put on those first couple of lines there. So as you're watching this video, you can pause this and then take a second to write these all in, and then we'll continue on with the examples. All right, so take a look at getting probabilities from a table here. Actually, one thing that I want to have you put down here, because it's not anywhere else yet, is the idea of complements. Complements are two probabilities that add to one. And then we'll be able to talk about complements a little bit more freely as we go on here. So we're looking at this table here. This is, I think, a survey of students and what school activities they're involved in. There were a total of 720 students, and this is how they answered their survey. So we want to find the probability that the student is selected at random and is involved in at least one activity. So at least one is important to know that means one or more. Okay, so 1, 2, 3, depending on how many there are. So if you, so I'm just going to write here, at least one, probability of at least one, that'd be the probability of 1. And then we could, so that'd be this here, but then it would also include that too. So we're going to add those two probabilities together. Okay, so a little notation here, capital P, and then a parenthesis means you're finding the probability of whatever's in the parenthesis. So the probability of at least one is equal to the probability of 1 plus the probability of more than 1. So we have those probabilities there. One would be 360 out of these 720. And more than 1 would be 144. And obviously we could, since we're dealing with parts of a whole, we could add those together first and then put it over 120, or 720, excuse me. So then that's going to end up being 504 out of 720, which is exactly 0.7. Now we're going to leave our answers either as decimals or as percentages. I really don't care. Usually I just leave it as a decimal because it's the easiest or it's the quickest. It's what I got from my calculator. So normally I'll just leave it as that decimal there. But if you want to write it as a percent, that's fine too. So the probability that they're involved in one or no activities now would be those two. So I'm just going to go ahead and find that probability. 1 or none by adding those two things. So it's really the same type of problem. I'm just showing you a different way to set it up there. I'm just going to add those two things together right away and put it over 720. Same idea, just adding the numerators of those fractions. So we're going to get 576 over the 720, which is 0.8. Okay, so probability distribution, we had that in our definition up here, is a function that gives the probability of each event in a sample space. Well, sample space is everything that could happen. Okay, everything that's possible in that event. It's also known as a probability model. It's a way to show all the probabilities and things that could happen. So the scenario that we have here is that we're going to be spinning two spinners. Each spinner has 4 possible outcomes, 1, 2, 3, or 4. So I'm just going to kind of show that here. This is a spinner. I'm going to just split it into fourths. So the spinner says 1, 2, 3, and 4 on it. This one also says 1, 2, 3, and 4. And then I'm just going to spin. It's got like one of those little arrow things on it that I can hit, and it'll spin around, okay? And it'll land on one of those numbers. All right, so those 4 outcomes are evenly distributed here. So the probability of getting a 1 is the same as a 2 or a 3 or a 4 on each of those. We're talking about and this is important, the sum of the numbers from the two spinners. So there's a couple different ways we do this. I'm going to use this table here to kind of organize my thoughts. In spinner 1, so I'll call spinner 1 that red spinner. Spinner 1, I could get a 1, 2, 3, or 4. And spinner 2, I could also get a 1, 2, 3, or 4. When we're talking about the sum of those two values, we could get a 2 if we roll two 1s. And then as you look here, this is just going to be going up by 1 as I go down that row there. Sum of 1 and 2 here, I would have a 3. Well, look, this would also go up by 1s there. And then you could finish filling out this chart accordingly. There we go. All right, so now look at the different sums that we have. The biggest sum that we could have is 8. The smallest sum that we could have is 2 when we spin those two spinners. And I know we could probably get that from just looking at what's going on here. But those sums only occur once each. The other ones occur multiple times. And you kind of see the pattern in the table. 3 occurs twice, 4 occurs 3 times. What we're going to do is use a frequency table over here in order to...
If you'd like a treat, please stop down to the office. Once again, teachers or staff left in the building, please come see us in the office. We have some extra treats. Teachers or staff, thank you.
Recognize that voice. Okay, we're going to put that into a frequency table over here. So the sum of 2 happened 1 time, 3 twice, 4 3 times, 5 4 times, and then it goes back down again. So a probability model, or probability distribution, I'm going to basically take what I have here and write the probabilities. Probability of me getting a sum, well, of 2, excuse me, it happened 1 time. Out of how many we had here, we have 16 different scenarios. There are 16 different possibilities. So 1 out of the 16 was a sum of 2. Same with the 8. So basically, I'm taking those frequencies from up above, and I'm putting them into this probability model. Now notice, a lot of these fractions can be simplified, and you are certainly welcome to simplify them if you'd like. I like to leave them not simplified just to easily compare them, kind of at a quick glance. So I keep them all over 16 here. Either way is fine. You can simplify them if you'd like. So what we're going to do is we're going to graph this probability distribution, or this probability model. So this is our probability graph of our probability model right here. And what we're going to do is we're going to put those different probabilities that are possible on the y-axis. So we'll try to space this out evenly as much as possible. So this is going to be 1/16, then 2/16, and then 3/16, 4, and then 5/16 here. All right, and then what I'm going to do is, so here, these are our probabilities. Let's label that here. And then what we're going to put on the x-axis are our outcomes. Okay, that's what goes on the x-axis. So I could get a 2, 3, I'm going to try to space this out evenly again here. 4, 5, 6, 7, 1, 8. I'm just going to graph each of those probabilities. 2 is 1/16. Make that. There we go. And so was 8. So I'm just going to put this one over here. And then we went up to 2/16. So these should be the same width. I had a little bit more time here if I wasn't being so rushed by the bell here. It'll probably take a little bit more time. They should be the same width. But then this kind of shows you the distribution of those probabilities. Now it just shows us really something that we can see from the numbers right here, that the smallest and highest sums are least likely to happen, and the sum in the middle, that 5, is the most likely to happen. But here's a real nice visual way to represent that. That is your probability distribution right there, or probability model. Okay, call it either thing. And actually, both of these things, just to make this clear, both of these things here, um, the table that we have here and that graph are considered to be probability models or distributions. One is just graphical and one is numerical. All right, the next thing that we're going to work on is a simulation, running a simulation, and that's going to require a graphing calculator. So what I'm going to do is I'm going to do that in a second video. And then make sure you have a graphing calculator, and we're going to seed that graphing calculator, and then we are going to do some random number generations on it.